Hello, lazy chemist, and welcome to today's lecture, which is going to be on covalent bonding. And we're also going to go ahead and do a thing that's called dot and cross. So, today's lecture, we're doing two things. We're doing dot and cross, and then we're covering the basics of covalent bonding. All right? And so we're going to go ahead and start by asking, what a covalent bond is. And a covalent bond for us in this case is going to be a bond that happens between two elements in which the electrons are shared. Okay? So let's go ahead and write that out here. So, covalent bond. And as we just said before, that's a bond between two elements in which the electrons are shared. Okay? And so, what that means is that it's going to be slightly different than ionic bond. Remember, ionic bond is a case where we had one element taking the electrons from another. And in a covalent bond, they're actually going to share electrons with each other. Okay? Now, Now, there's going to be some difference between a covalent bond and an ionic bond. Other than the fact that these are shared electrons, a covalent bond is also going to include only nonmetals. So only nonmetals are going to be involved. And how a covalent bond usually looks is it's going to look something similar to this, okay? Where we have one type of atom. So for instance, this is fluorine. And fluorine, as you can see, has 7 electrons on its outer edge. And what's going to happen is that when fluorine comes together with another fluorine, they're both going to share an electron, okay? And when they share an electron, that's going to make both of them feel as if they have 8 electrons, okay? And the reason that we want them both to feel as if they have 8 electrons is going to be because of the octet rule, okay? So we're going to also go ahead and cover this one here, which is the octet rule. And this is the rule that states that all elements want to have either 8 or 0 electrons in their outer shell. Okay? And we're going to use this rule for now because it's going to help us with the ionic bonding still. Because the ionic ones, the metals usually have 8 in their outer shell. Well, they'll usually lose an electron so that they have 8 in their outer shell. But, we're going to use this basic rule here. And this rule will help us go forward. And this is something that we've already been practicing when we've had, different elements take an electron or give up an electron. We've always tried to make it so that they end up having 8 or 0 electrons in their outer shell. Okay? And, this one here. I don't know. So even though we have this PowerPoint, I don't really know that we want to go ahead and go into it in much detail. Because for the most part, figuring out how these things share electrons is going to be much easier if we go ahead and draw it out. And how we're going to draw that out is through the dot and cross method. Okay. So we're going to go ahead and use the dot and cross method. And the idea here with the dot and cross method is that we're going to show bonds through shared electrons. Okay? And with these shared electrons and these shared bonds here, we're just trying to show that one electron is shared between two groups, between two atoms, to indicate that, they're cooperating to try and get to that octet rule. Okay? So, let's go ahead and go over the process. The first process, and this is going to be like the first formal process here. So for the first couple of these, you're going to have to do this formal process. And then gradually you guys are going to get better at doing this so that you don't have to do it quite, this long form process. Is that you would go ahead and draw out all the elements in your compound. Okay. You're going to go ahead and include their valence electrons. Then you're going to go ahead and bring them together and share one set of valence electrons for each element. Okay. All right. So let's go ahead and start with a compound, and we will go ahead and do NH3. Okay. So this is our compound that we're going to be working with. All right. We have one N and three H's. So let's go ahead and draw the N. And for some reason, N always gets represented by blue. I'm not sure why. It just happens that way. And we're going to go ahead and draw H's. And we're going to go ahead and just draw them around. Okay? And the reason that we're going to draw them around is that typically in a compound like this, you're going to have your central atom in the middle, and it's usually going to be surrounded by other atoms. And, that's just how it normally ends up being. Okay. Next, what we're going to do is we're going to go ahead and draw out the valence electrons. So we're going to show how many valence electrons there are. Okay. And I'm going to go ahead and show you guys what I think is the easiest way to, draw our valence electrons. And I like to just make sure that I'm drawing them in a specific order. And the reason for that is, it just makes it easier to count. Like when I go through these problems and I, as a chemist, go through them from my own notebook, I know how many electrons are based off of where the empty spot is. Okay. So here for this one, we're going to go ahead and start with the nitrogen. And the nitrogen, we're going to go ahead and have be the cross. Okay. And the reason we're going to have the nitrogen be the cross is because I like to always have the cross be the one that has, that I think is going to lose electrons, or is going to, the more likely to lose electrons. Okay. And actually nitrogen has a greater pull, so we're actually going to change it here. Sorry, messing up already. All right. So nitrogen we're going to have be the dots, and then hydrogen's going to be the cross. All right. So how we're going to do this is that we're going to go ahead and look back at our periodic table, and we're going to look at hydrogen, and hydrogen's in the first column, so each hydrogen is going to have one electron. And nitrogen is going to have 1, 2, 3, 4, 5. Okay. There we go. This is right screen. Okay. So nitrogen, we're going to do dots for nitrogen, and it's going to have 1. Let's make a bigger dot. So 1, 2, 3, 4, 5. Now, I like to draw them in that specific way, in that specific order. 1, 2, 3, 4, 5, 6, 7, 8. That's the way that I prefer to draw it, just so that I can see when we run out. Okay, and that's 1, 2, 3, 4, 5, 6, 7, 8. I've never had anybody bust me on, not drawing them in this order, and I don't think I've ever busted anybody for drawing them in that order, but, I think that's the right way to go about it. Okay, and then each hydrogen, as we said before, that had 1. Okay, so now we've drawn out our elements in the compound, and now we've drawn their valence electrons. Okay, and I want you to notice that for all the hydrogens we ended up giving X. Now we're going to go ahead and bring them together, and we're going to show that they're sharing electrons. All right, so that means that here we're going to have to go ahead and do N, and we know N is going to go ahead and share an electron with hydrogen. Okay, and we know it's going to share an electron with a second hydrogen. And the third hydrogen. All right. And so this right here is showing the bonding that we have between the nitrogens and hydrogens. Okay. Now, one quick thing that I want you to remember is that we did not end up using all of our electrons from nitrogen. Here we had 1, 2, 3, 4, 5. We've only used 3. So those leftover 2, we're going to go ahead and just put them together up top, because we have room for them there. And we're always going to make sure that they're paired, because electrons don't like to be lonely. Okay? The last thing that we're going to need to do is we're going to need to go ahead and draw just some circles around the actual bonds. Okay? So just in case anybody gets confused, we're going to have circles around like the actual bonds. We want to make sure that we're circling the entire elements involved. So this hydrogen and this nitrogen are bonded. This one and this nitrogen are bonded. And then this nitrogen and this hydrogen are bonding. Okay? And that's how we do the basic dot cross method. Okay? So let's go ahead and do another example here. And let's do... let's do PCl3. There we go. So we're going to do PCl3. This is also known as phosphorus trichloride, and you guys will get to see that in depth in a little bit. But we'll go ahead and start. We're going to draw our element right in the middle, and I guess phosphorus we're going to have the blue, purple, and we're going to have chlorines, and there's 3 of them. Whenever there's 3, I like to draw them on the bottom. I like to leave my top for the electrons. That's where I like to store my electrons. Okay. And my P, I guess my P, I'll go ahead and have that one have my electrons. So we have to go ahead and take a search here. P, how many electrons does P have? It has 1, 2, 3, 4, 5. Okay, so that means that we'll go ahead and do, let's do P electrons in blue. 1, 2, 3, 4, 5. Okay. Our chlorine, each of those is going to have 7. Okay, and I know that it's going to have 7 because I go 1, 2, skip these few, 3, 4, 5, 6, 7. Okay, it's also 1 away from this one, which is always 8. So, but chlorine's going to have 7 valence electrons. So we'll go ahead and go back in there and we'll draw 7. Let's change the color. Chlorine is green always green. So we'll do 1, 2, 3, 4, 5, 6, 7, 7, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Okay. Then we'll go ahead and connect them up. So, oh man, this is starting to look like a mess. Okay. So let's go ahead and connect them up. So let's go ahead and do P here. That's the wrong color. Don't want our element to be the wrong color now. Okay, so we'll draw our P here. And we know that the P is going to have this blue one. And we know it's going to connect up with each chlorine. So I'll do one at the top, one at the bottom, one at the side. And then we'll go ahead and change colors to our chlorine. So we'll do Cl. We're going to show one here for that one here for that one here for that one. We'll do Cl, Cl. And then we notice that phosphorus used 1, 2, 3. It has 5 total, so it has 2 left over. We'll draw those at the top. And then we'll go ahead and draw our circles, and let's do just black because this is already pretty colorful. 1, 2, 3. And this will be a lot easier when you guys actually draw it out than going over anything else. Alright, and so this is the basic way for us to go ahead and do dot and cross diagrams. A little bit later, we'll end up going over how to do something if you have double or triple bonds. But as you guys, before I forget, it looks like I forgot the extra electrons on the chlorines. Okay. So the chlorines, you would want to make sure that you also draw like their leftover electrons here. Okay, because each chlorine had, a total of 7. So don't forget those when you're going through here for the dot and cross diagrams. Now, in not too long, we're going to go over the process that I like to say for making Lewis dot structures. And to be perfectly honest, Lewis dot structures I feel are the more useful way of indicating bonds because it's a lot easier to draw than the dots and crosses. But I need you guys to get used to the idea that in these bonds that are being shared here, that one electron is being shared from phosphorus and one is being shared from chlorine. And that's the main point of the dot and cross formula, is for you guys to go ahead and see that's what's going on there. Okay, so for today, you should be able to work on the worksheet for today. And, that's really it for today. I'm hoping that you guys will have an easy time with this. And, for your homework, any of the first 3, I need you to do them like this formal way. But after the first 3, if you have a quicker way of doing it, if you've already figured out oh, hey, I just need to bind these up and then, the extras and count them that way, go ahead. Because, that's the thing about chemistry, is that eventually you're going to get so good that you can do a lot of these things the lazy way. But that's going to go ahead and close us out for today. And remember, whenever you do get the chance, go ahead and be lazy. That's the main point of chemistry, is finding new and interesting ways to be lazy, especially with calculating and figuring out how different functions work.